Morning. Today we're going to take the derivative of this function implicitly. Hopefully implicit differentiation has been explained to you or you've done some studying on yourself, so this will make a little bit of sense. But in these cases, the way we work this is we look at the y's as functions of x, and we derive with the chain rule, and then we solve for y prime, and it works kind of like this. And the reason is it would be very difficult to get a function, in fact probably impossible to solve for y and then take its derivative in this case. So what we do is when we have x by itself, we just take the derivative. We take the derivative of both sides of this function first of all. When we take the derivative of x cubed, it's just an x, so it's just the way you would normally take the derivative. It's 3x squared, and then I'll put a minus here, and I'm going to use a bracket. Now I have x times y. Well, that's a product. It's a product of two different functions. One's x and one's a y is a function of x. So the way we do that is we say the first function times the derivative of the second function. Well, the derivative of y with respect to x is just y prime. And then just continue with the product rule. The second function, which is y, times the derivative of the first. Well, the derivative of x with respect to x is just 1. So we get x times y prime plus y for the derivative of xy when we derive implicitly. Now we derive y to the third, and we say we look at the outside function. We use the chain rule, which is just 3y squared times the derivative of the inside function, which is y with respect to x, so it's just y prime. And then the derivative of 1, derivative of any constant, is 0. So now, generally what we do is we, well, I'll multiply this negative out first, and then we'll worry about that. So we get negative x y prime minus y plus 3y squared times y prime equals 0. First thing we do is we get all the non-y prime terms, so negative y and 3x squared, over to the other side of the equal sign. And when we do, we get y minus 3x squared. And then on this side of the equal sign, we're left with negative x y prime plus 3y squared y prime. Now we factor out a y prime, leaving, and I like my negatives being back, 3y squared minus x equals y minus 3x squared. Now we'd have, oh, sorry, that was a multiplication. I don't know why I put an equal sign there. When we factor out that y prime, we get y prime times 3y squared minus x. Now we divide both sides by 3y squared minus x to solve for y prime. And we get y prime equals y minus 3x squared divided by 3y squared minus x.